the experience we have with applications can differ greatly, right? We have applications that we really like enjoying interacting with, that we feel supported by. We have applications that we don't think about much, that we rather feel indifferent about, and we have applications that we feel quite frustrated working with. And it can be applied, being reliant on an application if we don't enjoy using it. Companies do a lot exactly for that reason, that we enjoy using the application. But what exactly does that entail? And how can we help Rust developers write applications that their users enjoy? And a lot of this is about UI. UI affects our sympathy significantly, and it can really, you can control how a user interacts with an application by making the UI really, really good. But today I want to put UI aside. I don't want to look at UI. We have heard a lot about UI before today in different talks. I want to look at everything beyond UI. So what makes us enjoy interacting with an application? We could look at one of these applications. Probably everyone knows these applications, or at least part of these applications. They do a lot of things right. They have huge teams of people working on them, and yeah, there's a lot to learn from them. They likely also do a lot of things wrong for business reasons often, but I don't want to look at them today. I want to introduce you to something else. I want you to learn about this. This is Deutsche Bahn Navigator, or the DB Navigator. This is the application of the German railway company. And to understand, I have to explain a bit about my background. I'm German, I live in the German countryside, and we Germans, we love trains. We really, really like trains. We like building train stations, we like building train tracks everywhere. And I mean it. This is a completely reasonable setup in Germany. This is a train station in the middle of nowhere, which is at a village with 12 people. They have to commute, so we build a station. Surprisingly, it's called Great Quasso. I don't know how many people live in Little Quasso, but... and we really expect this setup, right? When we plan our trips, we want to go somewhere, then we expect to be able to go there by train. But it's not just that we build train tracks to every small village. We also have these huge projects that make train stations a lot nicer to use. In this example, we have Stuttgart, a huge metropolis in southern Germany, where the train station just didn't cut it anymore. So what we did is we just dig underneath the entire city, build a new train station underneath, and then rip everything else out. And then we got like a lot of new land that we could use to build houses, to build new parks, extend the neighboring park, and so on. So, long story short, we Germans, we like trains. We love them. But then this company comes along. This is a German institution, the German Railway Company, and it operates all trains in Germany. And it's rather controversial. And the problem is that the Germans have a real desire to be on time. We like that about ourselves, and yeah, we like thinking about ourselves as people who like to be on time. And this company gets in the way of it, because it's really hard to keep a train schedule. And trains are very often delayed, and yeah, it conflicts with our desire to be on time. And it's a widespread opinion that the Germans do not like this company. And all of my friends could probably tell you stories about it. But it's not that we hate the company. It's more that we are kind of embarrassed, because what if tourists come to Germany, visit Germany, and they experience these delayed trains and they judge us by it? They can't even keep a schedule. No, like the worst thing that can happen is if a tourist tells us that they were in France and their TGV was on time. We Germans do not get along well with this company. And then this app comes along, right? That's the application of that company. You use it to search for connections, you use it to buy tickets, use it on while you're traveling to show the conductor your ticket and everything. And we Germans, we actually love it. We use it all the time. It's a good app. So how did that happen? How did a company that is so universally frowned upon in Germany, how did they produce an app so good that the Germans like it? I want to look at it with you together and try to figure it out. So this is what the app looks like, and that's already like almost all of it. There are some more features, but we will ignore them for now. It looks reasonable, looks okay. It's not a beauty, but it's also not like far from ugly either. But I don't want to look at UI. I want to look at the additional features that it has, everything that's not UI. And for that, on the left side, you see the planner. You use that to figure out a connection, to find a connection that you can take. And like, you have to type in your starting destination, and you type in your starting location and your destination location. And you can use a few features that make it a lot easier to type that information in. For instance, there's a button to use your current location of your device as starting location. It will find the nearest station, fill that in. You don't have to do that, right? Small feature, but very useful. Similarly, when you click for the departure time, you can click now. And it means it will use the current time as departure time. Again, very simple, but makes it very convenient to use. When you're searching for connections and you want to buy the ticket, you can use the payment information stored on your device to instantly buy the ticket, get it on your device. No need to type any information in as long as your device provides APIs for this kind of things. The next two pictures is what you would use when you're on your trip. Like when you have to show your ticket to a conductor, it shows you the pre-scaled QR code, fully scaled on your device, so they can immediately scan it and will get your ticket. There's a very fancy feature, very simple feature, but quite fancy and quite helpful. When you tap that QR code, it brightens up the display for 10 seconds. And it's so much easier for these scanners than to scan your QR code. Again, very simple, but makes life so much easier. You will get notifications, your device will use the rumble when there are delays on your track, trying to wake you up in case you fell asleep and you have to transfer and things like that. When you reach your seat, you can use it to scan an NFC code at your seat to automatically check in, so you no longer have to show your ticket in case the train supports that. So these are all very small additional features to the UI, but that make it so much nicer to use this application. It's not the only thing that makes it nice to use, but it makes like on top of the UI that's very easy to use, it's really, really great about this application. So despite being looked down upon by most Germans, like this company produced a really, really great app that the Germans like. And I would argue if you're an app, you want to be like it. So looking beyond this one application, I think different examples that I'm trying to talk about today is what is it beyond UI that can make an application feel like give a more immersive experience to the user? And this can be things like integrating with the ecosystem. This doesn't necessarily mean features of the app, but doing things the right way on the platform you're running on. Integrating with the contacts on the platform you're running on, integrating with the file manager, with the account system, but also interactivity, getting as much information from the user which is not just a keyboard. So using a camera, using a microphone or a touch screen. And on the other hand, getting information to the user with things other than the screen. So you can use a speaker, you can use a rumble device on mobile devices, you can use a backlight. You can also use peripherals and sensors to get like a lot of information from the device about, for instance, location, orientation of the user. You can communicate with devices that are near around the user using NFC and Bluetooth, or get device health information, react to battery status, for instance. And lastly, using the correct storage APIs of the platform you're on to differentiate between long-term, short-term storage for caching or for data even that might be synced to the cloud and so on. And using all these APIs, using all these things correctly can make it really, really nice for the user to interact with the system rather than fight it. To summarize these into, again, 3 categories that are all called one, is we should integrate with the OS and the ecosystem. We should try our best there to do things as recommended on the system. 2, we should adjust our decisions to the device we're running on. On a desktop system, we should expect our users to be less hesitant to type, right? It's so easy to type in information there. But on a mobile phone or a mobile device, we should expect people to be less hesitant to scroll through suggestions instead, rather than typing a lot of information. And 3, we should use sensors and auxiliary devices to get more information out of the platform where it makes sense, yeah. And all this is possible with the native APIs on these platforms, right? On Windows, on iOS or macOS, on Android, Harmony, on Linux, and even on the map, there are native APIs that provide access to all these kind of features. There's information on that, and it's possible to already get all this. And these platforms want you to use all these features because they know this makes it so much nicer. You don't have to fall down to the hardware level and implement anything on your own. No, this is all provided. But the big problem is all these APIs, they share a big problem, and they're not Rust, right? But that's why we're here. We want to improve the Rust ecosystem to give them access to all this. And yeah, we developed this 2-step plan to do that. The first thing we want to do as part of the plan is add native Rust support to all the platform SDKs. Make Android provide their SDK for Rust applications. Make Windows provide a Rust crate that gives you access to all the Windows APIs. And 2, use that to create portable abstractions on top. So yeah, this sounds nice, unlikely to happen very soon. It took Android, to Google 12 years, I think, to introduce Kotlin and as a second language, and Kotlin is very, very similar to Java, right? So I don't see this happening very soon. But we can start lobbying for this. We can start trying to convince people to do that. And for instance, Microsoft already provided really good Rust crates to interact with their system. So what can we do instead until we find this? And I think there's 2 things we can concentrate on. First, we can improve and document how you can build Rust for a specific platform. How can you integrate Rust code right now with all these platforms that I was mentioning? And 2, how can you access the raw APIs on each platform? Once we start providing access to raw APIs, everything else can be built by the Rust ecosystem itself. And that's why we started the Osiris project. The Osiris project stands for Operating System Interfaces in Rust. And we want to do exactly these 2 things for the mentioned platforms. And the mentioned platforms are basically all of the platforms that are currently used for the more capable devices, like mobile phones, desktops, and so on. This project is still under construction, and we're talking a lot about what we want to do, and it's still a moving target. So just as a warning, but yeah, we want to improve this situation. We want to ensure that the Rust ecosystem gets really good access in that regard. And other systems are already other systems don't have very, very good cross-platform support for all these APIs that I was talking about, right? They are all struggling a bit with that, and we thought it's a good moment to show that in Rust, we can do better. So what does Osiris give you? Osiris is meant as an add-on to your application, right? You still have to write your application. You use your UI framework or your business logic and everything, and you build it. And then you're not finished yet, but maybe it already runs and everything. But you add Osiris on top of it. And you have your bland application, you add Osiris, and what do you get? Right, of course, you get something like Deutsche Bahn Navigator. And how do we do that? We do 2 things. As I said before, we want to provide you APIs. So ideally, we end up with a way to provide you cross-platform APIs that you just include into your Rust code, and you can access battery information, device health information. You can access geolocation. You can access the storage information of your device. And secondly, we also provide a way for you to build for all these platforms. So we have an extension for Cargo, which allows you to produce the final artifacts for all these platforms. And this is a more complicated step than most people realize, because it's not just about building the application, but then following all the restrictions of the platform, building the final artifact that can be distributed via the stores. You have to support signing these things and everything. So these are the, again, got the numbering, something didn't quite work there. These are the 4 pillars of the Osiris project, and I want to focus on 2 of them, just give a few more details on them. And the first one is build system integration. And what's so special about that, and what do we try to do? And we really believe that we want to use the platform native build system on each of these platforms. And we think this is crucial because while we all have opinions on build systems, and there's problems with all of them, and some of them are slower, the others are faster, and it's a heated debate, but we really want to use the native build systems to make it a lot easier to pull in third-party dependencies. They often already ship with integration into the platform native build system, and by using it, it's a lot easier. We also automatically follow platform recommendations with using the correct build flags, the correct security options. Just imagine things like address layout randomization, other stuff. This is automatically applied by the build system usually, and automatically followed when you use it. You also got linters applied automatically because they're integrated into their build systems. And very likely it's forward compatible to how first-class Rust support would look like anyway. So yeah, let's do it that way. And as a second thing to keep in mind, it's usually also compatible to all the stores that are out there. Because if you're publishing applications through these app stores, they have quite strict rules. And if you don't follow them, you will, your users will be unable to publish their apps on the App Store. And this not only means that it's hard to install and update these apps, but it also means it's often impossible to install these apps in closed setups, like company setups, where they use these stores to limit the number of apps and that their employees can install on their devices. And the second thing I want to look into is into the APIs that we want to provide or want to describe. The thing we want to take care of is providing, unblocking early adopters in Rust and aiding contribution and collaboration. And this means giving them access to the raw APIs of the platform, because then they can start building things. If we start by providing cross-platform APIs, or if we start by handing out platform-specific abstractions in Rust, they are often things that users want to do which we don't expose, and then they have no way of doing that. And that's why we want to concentrate on raw first and abstraction second. And there are a lot of platform APIs already accessible in Rust, and we don't want to duplicate this effort. It's more about documenting how do you do things on a specific platform, which options do you have, why is a specific option recommended, or is maybe the vendor even providing their own abstractions. So this is the first thing we want to do. And the second thing is providing platform-specific abstractions in Rust. And again, we want to concentrate on the platform-specific part first, because writing a lot of platform-specific API, oh god, long weekend. I think I'll just skip over to the next one. which is a list of platforms we want to support. Oh god, I'm sorry, but oh, we skipped that one. But that's already it. I have no voice left, actually.
Okay. Let's see if there's any questions from the audience. Okay. So the question, I guess, is what are these available, or when are they available?
Right.
What parts are
So
available today?
we have, we concentrated on the build system first, like getting these APKs, for instance, for Android to build. So we support that, but we have a lot of, like, we're rewriting these things quite often to figure out a way to not tie it to Osiris, but find a way how all crates and crates that are IO can, oh god. I'm sorry. maybe choose later.
Okay. Yeah, thank you, David.